Hey, good afternoon. Good morning, everyone. Thanks for coming. We'll go ahead and get started. I'd like to welcome everybody. It was good seeing a lot of you last month, actually this month, 2 weeks ago at the science meeting. We're going to continue that discussion of research to operations today with Russ Barton from NOAA. I'm going to go ahead and give him an introduction and then we'll pass the baton over his way. Russ, I'll make you co-host now so you can go ahead and get your slides up while I introduce you. Russ Barton is the director of the Water Prediction Operations Division within the Office of Water Prediction. Russ began his career with CDM in Jacksonville, Florida, performing hydrologic and hydraulic modeling using EPA's stormwater management model with CH2M HILL in Montgomery, Alabama. His work included further modeling using DHI'S Mike URBAN and HEC's RAS, in addition to GIS development, information solutions, and software implementations focused on GIS-enabled enterprise asset management. He also had stops at water and wastewater utility and municipal governments, where he gained experience managing people as well as managing utility and public work operations. In May of 2020, he came home to hydrology when he joined the federal service at the National Water Center. Russ is a registered professional engineer in Alabama. He earned a Bachelor of Science degree in Geology from the University of Alabama and a Master of Science degree in Engineering Hydrology, also from the University of Alabama. And with that, I will pass it over to Russ Barton. Thanks, Russ. Russ, let's see if, yeah, we can hear you now.
Okay, good. Thanks.
Yep.
All right. And do you see my screen? Perfect. Well, let's get started. So I'll give a presentation today, and you still won't know what it's like to be in operations. And I say that because I was in another division here at the Water Center for my first 2.5 years or so, and 2 years maybe, before coming to WPOD, the Water Prediction Operations Division. And having been on both sides, I can tell you that until you come here and spend some time, it's very, very difficult to appreciate what happens in operations. So, having said that, I'll do the best I can. We'll take questions along the way. I do want to get through all of my slides if at all possible. And if there are questions, that might be a trigger that we need to have another session later on. And several of the slides that you'll see could be their own presentation, just that single topic. So for those who have not been here, this is what the Ops Center looks like. That particular photo was taken during Hurricane Ian last fall. We have coverage 7 days a week, 365 days a year. We will be able to be full-time 24-hour operations when we are fully staffed. Right now, we're a little over half staffed. We run 2 shifts a day, 5 a.m. to 1 p.m., and that's 2 people. 12:30 p.m. to 8:30 p.m., also 2 people. We augment that as needed, and we can surge to 24 hours for a limited period of time. Well, for a fairly extended period of time, actually, when we need to. And typically, that's driven by tropical events. We also operate a winter hydro desk beginning on or about November 1st and going through the end of snow season, which is usually end of May. We're doing that 7 days a week. This year, we're going to try to go to 5 days a week instead. There's not the time criticality associated with winter hydro that there may be with some other things. But should there be, we'll surge and handle that on an as needed basis. And finally, this year we did add another position in our shift rotation of a seasonal FEM flood inundation mapping lead forecaster, who happens to also be our FEM operations program lead. And that did a couple of things. It allowed him to work on the FEM program, which is fairly demanding right now, but also to be on staff. And if we did have the need to support the field with FEM, we have somebody baked into the schedule for that. We do produce 3 experimental products, and I'll come back to these in detail later on, but it's the National Hydrologic Discussion, which is a text-only product, the Daily Flood Hazard Outlook, which is text and graphic, and then an as-needed short-range forecast, short-term outlook called the Area Hydrologic Discussion, which is more localized, and we produce those, as I said, as needed. And there's the link. I'll provide this presentation, and there's a link that you can find our products. The annual cadence for operations looks like this, and you'll notice there's always something happening. We're still in tropical season right now, and that officially started back in May. It really ramps up usually in the summer, and then August, September, October typically are the busiest years, but there's no hard and fast rule on when tropical events occur. I mentioned winter hydro season. We also have the NHA spring flood season, NHA being the National Hydrologic Assessment, which is a product we produce, and you've heard that discussed here in this venue by one of our our senior hydrologist, Royce Fontenot. Then, of course, there's convection monsoon season, and at the bottom, water resources is all year round. That's an area that we're moving into more than having accomplished things in the realm of water resources at this time. We have 3 program areas that I do want to mention. The first is the Winter Hydro and Remote Sensing program. We do cold weather hydrology, the Gamma Airborne Snow Survey, which is, we use it to detect snow water equivalent. We run the National Snow Analysis, NSA, that's out of our office in Chanhassen, Minnesota. Our team does a product called River Ice Surveillance, which is really well received by our field offices that are impacted by frozen rivers. They also perform remote sensing in support of flood inundation verification when possible, when we have a satellite pass that comes close to catching the peak of an event. That's a useful source of potential verification information. And they do some ad hoc mission support using their remote sensing skills. And one example of that is last fall, Sean Carter with our group that leads that group did an analysis on the lower Mississippi showing the loss of area inundated or by the lower Mississippi. The next program is the FEM operational program. We don't create FEM in this division, we use it. It's created by the folks in our geointelligence division. We are in the position of providing direct support for our field offices. And there's quite a bit happening here. I think most of you know that FEM went public for about 10% of the nation a couple of weeks ago, and it'll go public for 30% in about a year. And then a year after that, 60%, and a year after that will be at essentially 100%. I won't read this slide, but suffice it to say, we are primed and ready to support our field offices with reach back capabilities. And we're able to do that even if there are multiple fronts, which can happen. It's not uncommon, actually. And finally, our water resources program, which I will say is somewhat in its infancy. We currently do the National Hydrologic Assessment in the spring, which I mentioned earlier. We also coordinate the Greater Mississippi River Basin coordination calls. CIROH, Forecast Informed Reservoir Operations, is becoming more and more important. That's typically done by our RFCs, and the Corps of Engineers has expressed interest in expanding that. So that's listed under one of our future areas to be considered. We also want to look at maybe not doing the NHA as a single issue product, but as something that we do on a recurring basis, at least through the season, if not all year. And we also want to take a look at extending the outlook for the things that we do here, doing more long range forecasting, whereas right now we stay within the short and medium range forecast. And finally, we want to do some dry side visualizations, which we've not done to this date. So, what does our staff look like to perform this? We won't go through all the gory details. You can read it there. But suffice it to say, we have a number of hydrologists. Most of our positions are hydrologists, but not all. We do have an AWIPS administrator, AWIPS being the Weather Services primary forecast platform. We have 3 GIS specialists, 1 software engineer, and 3 members of our management team. We're not at full staff, as I mentioned earlier. We're, I think, at 22 right now. We're billeted to be at 39 when we're fully staffed. And the hydrologists that we have are geographers, geologists, engineers. There's a broad background of folks that, and even meteorologists that come to us and become hydrologists. Okay, definitely not going to read this slide. The point of it is, what resources do our forecasters use? They use anything they can that's going to give them some situational awareness hydrologically. And I'll pause here just for a minute and let you read a few of those. One that's not on here is Atlas 14, and that's one that we use. I like to use often anyway, and our forecasters use it as well. So that when we have a significant storm coming or event coming, we'd like to see what that means in terms of annual recurrence interval from a precip perspective. We know that doesn't correlate to a flow perspective, but it gives us an idea of the severity of what may be coming. So how do we take that information and do something with it? I think most of you know our daily driver, if you will, is the National Water Model. And the primary output that we use from the National Water Model is stream flow. So we take that stream flow, again, that's 3.4 million stream reaches, and we try to visualize it in ways that will give us a sense of what may be happening or will be happening soon. These are a few of the visualizations based on National Water Model stream flow. We have the high flow magnitude. I think that's self-explanatory. We have the high water arrival time, high water probability, rapid onset flooding, stream flow anomaly, and then I mentioned earlier we have FEM for 10% of the nation. All of the visualizations listed on this slide are public, and you can get to those through our ops page. So I mentioned high water several times, so I think we should take a moment. And by the way, if there's anything coming in through the chat, I don't see that, so I'll leave that to you, Zach, or others to curate that. What does high water threshold mean? So a couple of years ago, we were using the term bank full. And most of you probably realize that there's a geomorphological construct of bank full flow being equated to an annual recurrence interval. A lot of work has been done on that. When you don't know the actual channel geometry, it's very hard to pick the point at which true bank full flow occurs. So we felt like calling something bank full when we didn't have the information that would actually indicate it was bank full and about to be out of bank was a little bit misleading. And we had a team of folks in other divisions or led by another division work with our field and come up with a different term. So the term that they came up with is high water. And we can debate on whether that's a good term or not, but that's the term that was settled on. But we need something that will tell us, okay, a stream is about to get out of its bank. That's really when the interesting things start happening from a flooding perspective. And this is an important threshold because it triggers really everything that we look at. It triggers the natural water model derivative products that I mentioned. It triggers how we evaluate the natural water model. And it importantly triggers the production of FIM. And it is our surrogate for bankful. And long story short, we take the retrospective model simulation for the current version of the national water model, and that's about a 41-year period. We take that retrospective data, treat it as if it's an observed data set, if you will, and calculate annual recurrence intervals. We temper that with some work done by McCabe and Wallach on runoff efficiency in hydrologic clusters that are of like performance or of like runoff efficiency, so that we can assign by those clusters the annual recurrence interval that will apply for, quote, high water for that cluster. This is one of the slides that could have its own presentation in and of itself, but suffice it to say, there's a little bit of work behind the scenes to establish what the high water discharge is. This is one of the services that was listed on the slide of currently public services. This is the rapid onset flooding. We call it ROF. And what you're seeing here are, well, let me define rapid onset flooding. This is somewhat arbitrary, maybe ripe for additional research, but it's a doubling of flow and crossing the high water threshold within the next 6 hours. Again, that's, we can debate if that's appropriate or not, but that's how it was identified, and that's how we use it. So the stream segments you're seeing are projected to go into above threshold and double in flow and be above threshold in the short range forecast horizon, which is an 18-hour outlook. We then take those and we look at the number of reaches within a HUC and code that or display that by percentile. It color code that. So it draws your eye to where we think, or where the forecast would have you think the highest probability for something of significance to happen. We also do this for medium range. It's not used very much. This is more of a short range product, but we have done the same thing for the medium range forecast. So anything that I showed on the slide earlier about derivative products, and I said they're public, they're available here on the page on the right, and there's the link for it. And they're available as REST APIs. So you can hit them as a service and consume them just like we do. And then also on the bottom right there is the FIM10, the link to FIM10. And you can see all of this that's publicly available in the National Map Viewer if you don't want to bring it into your own GIS system. Okay, I mentioned them earlier, but I'll go through really quickly our experimental products. The first is the Flood Hazard Outlook. As a reminder, this is produced once a day. It is meant to give both CONUS and OCONUS an overview of flooding potential for the next 7 days. It's a high-level product meant to draw your attention to areas of interest, mainly for our national partners. FEMA is a big user of this product, and other national partners as well. It goes out 7 days. We bend that from days 1 to 3, days 4 to 7, and then days 1 to 7. We also bring over from the RFCs any river forecast points that are projected to go into minor, moderate, or major flood. And this is available as a static map from our operations page, but once again, you can also consume this as a service as well. The next product is the National Hydrologic Discussion. It is a full text product, no graphics associated with this. It's not only looking at the national water model, nor is it only looking at the flooding side of things. It'll look at dry side and anything that may be of import. And I should reiterate that all of these are experimental. They have not graduated to be operational. While you can get to these on the web, they're still experimental products. And I can tell you that we do want to tweak these. We want to also ask tough questions. Questions like, does this product hit the mark? Does it scratch an itch, meet a need? If it doesn't, we don't want to waste anybody's time putting it out there, and we don't want to waste our time producing it. And all of you can go to the website there and provide feedback on all of these products. And I hope you do. We would appreciate any feedback. The other thing, there's no reason that we can't come up with additional products in the future. And that's kind of exciting to me. Third and final product, area hydrologic discussion. Again, these are when something is happening more localized and we can see it, and we want to draw attention to that area for the weather forecast offices. They're our primary intended audience for these products. This particular one is from New Year's Eve of last year, which was really the beginning of the first round of atmospheric river precipitation in California. And there's a lot happening on this graphic. Not too difficult to know where to draw the boundary for that area hydrologic discussion. Let's see. So what are the tools that we use to make these products? The first tool we have is the National Water Center Operations Dashboard. We call it the WPOD dashboard. It's built on the Tethys platform, which is an open source GIS web publishing platform. If Dan Ames is on the call, he could probably tell me how I may have gotten that wrong, but it's a pretty nice tool. And again, fully open source. So this is the tool that our forecasters use to go in and select HUCs. Typically, they're working at the HUC 8, HUC 10 scale. They actually are selecting individual HUCs that then get aggregated to make those boundaries that you saw on the FHO and the AHD. That's all done from within Tethys. Second tool is WaterView. This is based on ESRI's ArcGIS Online platform. This product is used both internally and also by our certain of our national level partners like FEMA. FEMA is a big user. If not WaterView directly, then the underlying services that are attached to WaterView that you can hit directly. WaterView has some nice features, and we have other products that are built on this same AGOL platform besides WaterView, and those are the FIM Reviewer. We do a lot of FIM reviews in support of our field offices to give them an idea of how well FIM is performing in specific areas. We have a tool for doing that that's built on AGOL. We also have a tool for georeferencing impact statements. So each RFC at each forecast point should have flood impact statements listed on the website for that forecast point. And the tool that our team created allows them to go in and take that text-based impact statement and represent it spatially, which is kind of a nice thing to do. Um, and we did a pilot on that last year. It was very well received and quite likely will be rolled out nationwide. The only kicker there is it does take time from our folks at the RFCs. Some of them are understaffed and they have very little time to spend on that. Some of the other tools that we have, I mentioned doing FIM reviews. We've got an automated tool for populating those notes. It doesn't do the FIM review for us, but it feeds the notes that are a critical part of that process. We've improved our system monitoring capabilities. I'm not showing that here, but we've got a lot of services, a lot of software, and we need to know when something's not working, where the problem lies. First of all, we need to know that something's not working, period. And then we need to know where the problem lies. Um, Third bullet there, the first look FHO using machine learning approach. One of our forecasters does this during his admin shifts, and it's pretty cool. He calls it a first look FHO. To me, it's almost an automated FHO. His tool is on the top, and the actual FHO that was created by staff is on the bottom. And I will point out they while they are different, they are similar enough that it's very encouraging. Whereas the first look FHO highlighted the central part of the country. If you look closely, we have some boundaries here and here that are the C text. C, as in look with your eyes, C text. Doesn't rise to the level of being a limited, considerable, or catastrophic risk of flooding, but it's something you may want to note. So if that were shaded in on the bottom graphic, you would see these are even more similar than they first appear. And finally, HEFS. Hydrologic Ensemble Forecast Service was completed for all of the forecast points last June, and we are still working to make that a part of how we produce things here. We've gotten really good feedback from the RFCs on this product. And the graphic I'm showing here was actually created by our water center director, Ed Clark, in support of the low flow situation on the Mississippi River. So he reached out to the Corps and asked what flow would stop or reverse the salt wedge intrusion issue that they're having. And they said it will slow at 200,000 CFS and it will begin to retreat at 300,000 CFS. And if you look at this ensemble forecast, which goes out through, looks like about November 7th or 8th, it's not very promising. To really begin to see a difference, we need to be up at that upper bound, and it's not even in the remote edge of the forecast. But HEFS is another tool that we use. I'm closing in on my slides here, so hang with me. Challenges faced by operations. I mentioned those high water thresholds. They can falsely lead to too many stream flow signals being, too many streams lighting up or too few. We know this is the way we know this to be the case because our forecasters match what they're seeing from the National Water Model and match what they're seeing through other sources of information, and they can identify areas where there are problems with the threshold, and we've identified those. The Wabash Basin is probably the classic example there. Secondly, the performance of the National Water Model is largely unknown except at stream gauge locations, and there's about 10,000 stream gauge locations, 3.4 million stream reaches in the National Water Model. You see our dilemma there. I tend to call the areas that we model away from gauges, I use the term hinterlands. They're just out there, and we really don't know much about National Water Model performance in those areas. Third bullet, performance of the atmospheric forces driving the national water model have a direct impact on the output of the national water model. That goes without saying, but it's kind of important to say it. And there's really two pieces of that puzzle. One would be to have better atmospheric forcings eventually in the future. But the first part of that problem is, okay, we are where we are today. How can we use what we have today and communicate that in a way that provides useful information to our partners, our field offices, and the public? Next bullet, data is a barrier, whereas it should be an enabler. And in fact, we've got a little bit of an internal effort beginning to look at data management in this way. And I like to state this bullet in the affirmative and say that we envision a future where data is an enabler, not a barrier. Next bullet, we are, especially with film, we are communicating to the public on a topic that they're largely unfamiliar with. And we're doing so using terms that have little or no meaning to them. Hydrograph, bank full, high water, annual recurrence interval, things that probably don't resonate with the typical American public. And finally, to me, I use this phrase, the absurdity of hydrologic prediction. And that's the expectation that the forecast will have some greater resolution and accuracy than any of the building blocks used to create that forecast. We don't have that expectation, but I'm thinking the public will. And when we show flood inundation maps, we're showing a polygon on a map, a line on a map. That's a very definitive thing that was derived from some very uncertain things. So, bit of a dilemma there. So, some thoughts on from an operational perspective, and I'll use the Congressman John Lewis phrase. He would say, "Make good trouble," or "get into good trouble." I may get into a little bit of good trouble with this group today, and I do that the same way that John Lewis, Congressman Lewis, did, which is with love. CIROH is the only cooperative institute with the word "to" in its name, and that preposition tells you where your research is intended to go. And if you go to the dictionary, one of the functional uses of the preposition "to" is it's used as a function word to indicate movement or an action or condition suggestive of movement toward a place, person, or thing reached. So we know where we're going. So I would ask, what if every researcher funded to do research via CIROH was selfless with the courage to tackle projects with the sole purpose of improving operations? There are many, many, many topics, and any topic that any of you have ever thought of and or working on, I have every confidence is an important topic. But is it a CIROH topic? Can it find its way into operations? So what does it look like for research to find its way into operations? Probably the best example there might be flood inundation mapping. It's something that started as a summer institute project and then found its way into operations. That took a little bit of time. I think we got to change that time. I think I don't know what a reasonable time frame is, but I'm thinking if you asked Ed Clark, he would say research it for 2 years, take a year, and get it into ops. And there's an imperative to do that because if it's going into ops, it's because it's going to make a difference, and that's what we're here for. So, how quickly can your work protect life, protect property, and enhance the national economy? and what is it going to take to get it there. And then finally, how can we at OWP demystify operations for CIROH? The good trouble I'm making and then stirring up some thought and some emotions, I hope, I make knowing full well that we really maybe haven't opened the doors to operations quite the way that we should. And there's a reason for that. Um, the folks down here are working shifts, and it's difficult for other divisions to schedule a meeting with one of our forecasters because we track our forecast shifts over in another uh, spreadsheet. They don't show up on your Google Calendar. So it's really, you think you're getting a meeting with someone. Turns out they're not even working that day. That's one of their rotating shift off days. I say that to say I, I don't think it's a healthy exercise to have all of CIROH pinging folks in operations. I think it's a very healthy exercise to have all of CIROH interested in operations and engaged in operations and building your list of questions for operations. And my commitment to this group is that we will find ways to make proper connections. We'll have, on the CIROH side, work through Dr. Burian, and on our side, we'll work through Ed. But I would love to see people come here for a week and just shadow, make notes, ask questions. If it's not too busy. If it's busy, we just want you to make the notes and ask the questions later. But I think the closer we can make the more narrow we can make the knowledge gap between research and operations, then it's a shorter bridge to build. And finally, I will say that at least one of our research hydrologists in another division has expressed interest in doing more with operations, maybe even being in operations, because I think they see that to tackle this beast, they need to understand it. So we're starting to get a little interest in that front. I believe that's my last slide. It is, and with that, I would be happy to answer any questions that you may have. How do we do on time? Pretty good. Man, Zach, I meant to be terribly engaging, but I may have put people to sleep. I'm not sure.
I think it was great. Let's see what questions people have.
Good question, Steve, about the mailing list. Is there a mailing list? So we're using Slack inside. It's not an external facing thing right now for a lot of our communications. If you guys know about NWS Chat, it was an internal but open to partners chat room, and it had to be replaced because it couldn't scale. So we're using Slack now. Those things are published out through Slack. I'll check and see if that's an option. And then the other thing, you just go there every day, and if it's a daily product, you know what time it is produced. And I'm not sure how we would flag you about an AHD. That's a good question. I'll check on that. Looking at it, I can't seem to actually pull up the maps. James, there was, thank you for asking that question, James. There was an issue noted late last week, about the FEM10, and that is being worked on. It is a known issue. I would give you an estimated time for that, but I don't have one myself. Can't imagine it's a difficult thing to fix. Anything else?
Let's take Andy's and then we'll go to Martin Clark.
Yeah, I don't know if you are reading out of the chat, but I'm curious about one other aspect that could be an obstacle to transition. I recall from working in NOAA before that I think we were told that for a new thing to be brought in, a model or some particular data set, there would need to be just 24/7 backup so that if you're on a Saturday night and your tool breaks or or your model stops functioning, you can call somebody and they can get into your system and fix it from OHD back in the day or now from OWP. And I wonder, is that kind of standard applied to a lot of the new developments that you expect to roll in, or is there a more trial period where they could be considered a tiny bit less reliable?
So the process is called the 10102 process. You can actually Google that and see a nice little flow chart. 10-102 National Weather Service 10-102. It's a directive, and that describes the process of going from prototype to experimental to operational. We're Everything I showed today is at the experimental stage. When you go to operations, yes, there is a higher degree of reliability expectation there. And I know Fernando is dealing with this on the FIM side of things, because you're exactly right. We You have to show that you can support this thing 24/7. And on our side, I showed the Tethys WPLD dashboard built on Tethys, where we create the AHD and the FHO. Right now, today, I would say that probably doesn't meet the Weather Service standard for reliability. It's something that we're working on. It's a very robust software, but things can happen. But yes, when you make it to that operational stage, it should be hands off, bulletproof, and if there is a problem, who do we call to fix it? That is still a requirement. Yes.
Great, thanks.
Mm-hmm.
Marty Clark.
Yeah, hi Russ. Thanks very much for your presentation. It was very, very interesting. I had a question about your last slide when you were talking about the timeline to operations, and it would be great, if we can implement things in operations like really, really quickly. Some of the work that is going on in CIROH is got a longer development timeline. I'm thinking about some of the work to improve the national water model and then how that national water model may ultimately be used in operations. Or some of the work that could transition to operations wouldn't be a new operational capability per se, but some capabilities for model testing, model evaluation, etc., that can help the National Water Centre determine the operational readiness of new technologies. So I'm wondering if you've got some comments on those, like longer timescales and like the broader model ecosystem work that's going on, and how you see that fitting into the R2O process. Thank you.
Martin, I'll leave that for our chief scientist, Dr. Fred Ogden, and Trey Flowers in our analysis and prediction division, where the model development occurs. Clearly, there are things that you can't go quickly on. We've been working on the next gen ourselves. It's already been in the pipeline for 2 years, more than 2 years now, maybe. And then we won't see an operational national water model based on that until I think it's late calendar year 2025, maybe early calendar year 26. So I think there's a tacit understanding that certain foundational things like the next gen development tools and the test bed and the evaluation capability, because it is going to be quite a chore, I think, to determine if something is better, when better may be better here but not better there. It's going to be, I think it's actually going to be fascinating to see how that plays out. I would say those things have to walk at their own cadence, but I would counter that and ask if there's ever anything you see that, hey, this could be an early win. If we shunt this capability off over here on its own track, it might be something that's um, that's worth fast tracking over here on its own while we continue to build the foundation. And really, Martin, your question is better answered by others rather than me, but that's the best response I can give you to that today.
Well, that's wonderful, Russ. Thank you for sharing that.
Okay, we've got a bunch. Let's go to Peggy, and then we'll go to the chat, and then we'll go to Jason. So Peggy, want to go ahead and...
No, I didn't have a question, but I had some follow-up information for Steve and James, and I chatted there. But I guess I'm going to go ahead and say it since you pointed to me. One thing, Russ, perhaps we can explore is that we have our Slack channel for our partners, right? There we notify whenever we issue products, and I wonder if we can utilize that for CIROH researchers. For easier communications. And then I think what I wanted to note on the FIM is that to James, James and others, that FIM is actually delineating over the FIM 10 areas, and I had to confirm that to make sure that the issue Russ mentioned is still ongoing, so I had to double check on that NWS GIS viewer, but it's still actually delineating. The kick is that the FIM is delineated within the FIM 10 area where a reach is expected to meet or exceed the high water threshold, right? So in order to confirm that, the easiest way is to use another service called medium range max high flow magnitude forecast. And whenever you see some colors within the FIM 10 area, you can turn on the FIM service, and then if you zoom in, the FIM service should show up. I know that that's probably something that's better if I can demonstrate it, but just wanted to let you know that's how you can find where the FIM might be.
Thanks, Peggy. Zach, you want me to take the question you re-chatted there?
Yes, sir.
Yep. Yes. When a new version of the National Water Model goes live on WCOS 2, we do update the thresholds. I have to admit it doesn't happen concurrently or prior to the go live for that version. So National Water Model version 3 went live a couple of weeks ago. We do not yet have the thresholds created for that version of the National Water Model. The retrospective simulation lags a little bit, and then we have to have time to do our work, or ISED does that work. So the last I heard from them would be late November, early December, before we actually have updated thresholds in place for National Water Model version 3. And it's a little bit kludgy. What that means is right now, today, we're using thresholds that were based on National Water Model version 2.2. That's something we're also looking at, how to change that that timeline.
Jason?
Yeah, I was just gonna, am I audible? Yeah, I was just gonna make a comment. Russ, to kind of amplify that slide you had about all the various data sources that WPOD uses, kind of in the context of questions about the National Water Model and next-gen development, there's rightfully a lot of excitement about how to get CIROH research and your research, if you're in CIROH, into the National Water Model. But with regard to operations, operations pulls in a lot of data beyond just the National Water Model. It's the National Water Model is one source among many that our operations division uses to formulate guidance. And there's actually a lot of other opportunities for research and research operations, I think, beyond just flat out hydrological modeling. So, there's questions here about one, how to characterize and quantify the uncertainty of model output in a way that's useful to operations. Russ has already mentioned questions about like the best way to use the retrospective data to inform these high water thresholds. And even, more basic informatics questions about how to organize structured and unstructured data, among many, many other questions beyond just how do we improve the model. So I just wanted to make that comment.
Thanks, Jason. Okay, Zach.
I will pass it over to Steve for some closing remarks. Thank you again, Russ. We look forward to these webinars every month. We'll have another one in November, and the speaker is to be announced. Steve?
Thank you, Zach. And I just wanted to close out by saying thank you to Russ for taking the time, and your colleagues, Peggy, Lee, and Jason, Regina, for also joining. I think you are helping to demystify National Water Center operations for the CIROH researchers. And I'll note for all on the call that Russ and Peggy and Jason and others from WPOD and the National Water Center continue to actively engage with CIROH, also attended the science meeting. And so it was great to see them there, and those that were there had a chance to meet and talk to them. One other thing that I did want to note is there's always more opportunities to learn about different things. And one thing that is coming up, and I'm going to put it in chat, is a webinar this week. And although Jason noted that operations is much bigger than the National Water Model, this is a seminar that is about the National Water Model. And so it's a good time to keep your brain active on things related to operations and the use of the National Water Model for delivering predictions. So thanks again, Russ. Much appreciate the talk and the time, and thank you all for joining, and thanks Zach. See y'all later. Bye.
Thanks.